Welcome to solverfy.
Given the direction of current, which is clockwise over here, we know that the magnetic moment mu should be into the plane of the paper or into the plane of the screen. And this means that mu should be along negative z direction. Now let's find the value of mu. So we know that mu is equal to negative mu k cap, where mu is just the magnitude of the vector mu, and negative sign is due to the direction because the magnetic moment is in the negative z direction. Now we know that the magnitude of the magnetic moment is given by current times the area, and here you can leave this answer to be like this, or you can simplify it by saying that the area is pi r square, because this is a circle. But in this case, since our b naught is given in terms of I times a, so we are just going to leave the magnetic moment with this expression. Now for part p, so the torque is given to be this value, and mu is here that we calculated, and we know that magnetic field can be written as a sum of its components along the three directions, so like this. And we know that tau is given by cross product of magnetic moment with the magnetic field. So let's solve these two equations. So we have negative ia coming out because this is just a value, and we can write bx times k cap times cross product with I cap plus by k cap cross j cap, and the third term is basically 0, right? Because the cross product of the same vector with itself, of a vector with itself, is basically 0 because the direction is uh, they are parallel, so they're in the same direction, so that is 0. And we can simplify this, and this becomes ia by I cap minus ia bx g cap. So this comes from the expression that k cross I cap is positive j cap, and k cross j is negative I cap. And so this is the torque with its components and magnitudes and direction, obviously. Now we can compare this expression to the one we are given over here. And comparing this, so we basically compare the components. So the component along x direction should be compared with the expression given. So ia by should be equal to 4 times d, and we do the same for the x component. So that is negative ia bx equal to negative 3d. So from here we get that by is equal to 4d over ia, and bx is equal to 3d over ia. Oops. Okay, let's just write this in the next page. So we got By to be equal to 4d over Ia, and Bx is equal to 3d over Ia from these two equations that we got from comparing the components of torque. Now we see that Bz doesn't contribute to the torque. From here only we can see. And this is because the mu is along z direction. And since torque should be perpendicular to mu because of the cross product, there should be no component of torque along z direction or along v direction as well. So, but we know that the net magnetic field B is equal to B naught is given to be this value, which is 13D over IA. And we also know that B being the magnitude, it should be equal to Bx square plus By square plus Bz square root over. So we use these equations to find Bz. So we are given B naught to be 13D over Ia. This should be equal to Bx square. So let's just write it in this form. So I think that will be much simpler. So we square both the sides. So we are left with this square is equal to Bx square, which is 3D over Ia square plus 4D over Ia square, which is your By, and we have Bz square. And from here we can calculate Bz, which will be plus minus D over Ia 169, which is 13 square, minus 3 square, which is 9, minus 4 square, which is 16. This calculation is really easy, so please try that. And this is equal to plus minus 12 D over Ia. And the thing that the potential energy is equal to negative mu dot B, and mu is negative determines the sign of Bc. So now you can see we have two possible magnitudes for Bc, and U should be negative here. So let's see what we are getting for the potential energy using the values of mu and B that we have. So mu is basically negative Ia k cap dot product with Bx I cap plus By j cap plus Bx k cap. And this gives mu to be positive of Ia Bc. And since, not mu, U, the potential energy U. And since U, potential energy, should be negative, we should have Bc to be negative. This means that this is the value of Bz that we should take.